everybody. My name is Ryan. I'm a co-founder of Coding Nomads, and here with me today is Shadas Yetkin. Shadas is a data scientist who lives in Hungary, and today we're going to learn all about Spark, DataBricks, big data, all kinds of stuff. I'm really excited. Thank you for joining us today, Shadas.
You're welcome. Really, it's a pleasure to be here. I am really excited.
Great. Yeah, thank you so much. So let's jump right in. What are we going to learn about today?
Well, it's going to be mainly about big data, Spark, and DataBricks. I think we can summarize them under these three topics. And of course, it's going to be an introduction material, nothing advanced here. We will talk about what big data is, how it came into existence, why Spark was necessary, and how it came into our world. And then we will talk about DataBricks, why we need this product, why people are using this product. And then, of course, we will have a notebook and we will do some simple analysis. I will try to show how Spark works in action. I will try to talk how Spark works in parallel, for instance. And then slowly we will finish.
Nice.
That's the plan.
Well, lots of good stuff in there. I'm really looking forward to learning about this. As I've mentioned before we started recording, before we started Coding Nomads, my career was in, well, at least a big part of my career was in big data and distributed processing. But it was kind of before Spark and before DataBricks, or as I was leaving that job, Spark and DataBricks were very much on the rise. So I'm very personally interested in what we're going to learn today. So, thank you again for being here. And let's just dive right in. To give context for anybody who's watching this, what is big data? It's a big term, it's a buzzword. What is big data?
Yeah, especially back in 2010, beginning of 2010s, I guess it was a hype.
Yeah.
It was already in Gartner's hype cycle. There were articles about it, people were paying huge amounts of money for big data developers, and even people with small data sets, they were interested in big data architectures, and then they were claiming that it is slow, it's not working, but that's what hype is. When it's hype, it's crazy. However, the emergence of DataBricks and the plateau of productivity starts somewhere around 2014, I think. That's when Spark really takes off. The big data concept, of course, back in 2004, 2005, people didn't have a framework to process large data sets. And back in 2004, 2005, it was around 5 terabytes. It was close to impossible to process if you had data larger than 5 terabytes. And perhaps you could, but it would be much expensive. We didn't have an open source project for that. And there was a guy called Doug Cutting. I think he's still around. I don't know if
What's
he's
his name?
Still Doug Cutting.
Okay.
He's the inventor of Hadoop.
Okay.
Yeah. So of course he was standing on the shoulders of the giants. He had lots of other libraries.
Right.
But he was working on this project called Hadoop, and he was successful. At the beginning, it was working with 4 or 5 nodes only, but Yahoo hired him. Yahoo was the early adopter here in this innovation. That's how it started. And actually, the concept is really something very simple. I like this analogy of animals and the carriage. In the Middle Ages, when people had larger and larger loads, they didn't look for larger animals. They were tying up animals together, right? And that's actually very similar to our parallelism here in the computer science.
Can you, I'm not totally sure I follow. So do you mind repeating that analogy or that?
Sure. So in the past, when people had larger weights to carry from point A to B, they were not looking for larger animals.
Oh, because like they would, the animals like the pack horses or the
yes, horses. They were tying together lots of animals, lots of small animals, perhaps, and in this analogy, cheaper animals. And that's also very similar to big data computing. You bring together lots of computers, you create a cluster, and they can process much faster if your data is big.
Right.
Or another analogy which I like is counting all the books in the library. If I am alone, it would take for me days, perhaps weeks. But if you can bring together lots of students, they can count together, and then they can give the result to me. And in this case, I am the driver.
Right.
I am the orchestrator, and the nodes are returning back the results to me. And in that case, we can count all the books in the library much faster. So this is how big data parallel computing is going under the hood.
And then, but in the actual computational sense, each one of those animals or each one of those students would be a node in the, like a server in a cluster of servers.
Exactly. Yes.
Okay.
Yes. In Spark, in each Spark application, there is a driver and executors, lots of executors. The driver is orchestrating everything, and all of them are JVMs.
Okay.
Yeah, driver and executors. This is the first level of parallelism. And under the executors, there are slots. Think about them like cores you have. That's the second level of parallelism. You are further distributing the task. And the smallest unit of computation is one task. So in one executor, there can be several cores, and they can execute in parallel and return their results to the driver.
Right.
Yeah. So yeah, basically, this is the abstraction. You know?
Right.
And these are really different than just the other kind of analytic processes I have done in my life.
Right.
For me, it was difficult to grasp. Yeah.
Yeah. Well, it's easy to think about a single server, for instance, reading a single file, even if that file's got 5 million rows in it or something. But as soon as you start thinking about multiple servers executing in parallel and basically the orchestration, right? Giving the appropriate task to the appropriate node or core or executor.
For sure, we have other kind of problems here than a single machine. Yeah. Including the cost.
Right.
Yeah. And I just remembered I didn't make the definition of big data actually.
Yeah, that's actually what I was about to ask.
The definition I like is big data is that kind of data which breaks your single machine. So you are not able to process it on your laptop or in your PC or Mac. You need more machines to process that. So this is the
would you say there's like you mentioned 5 terabytes earlier, is that kind of is there kind of an actual sheer data size in terms of bytes or terabytes, you know, where you hit above 5 terabytes, it's big data, or is there kind of a line like that?
No, the size is changing over time, you know. At the beginning, back in 2004, I mean, it was 5 terabytes.
Okay.
It was a kind of threshold for the people. But I don't want to make a definition with the size. The important thing here is the parallelism, computing in parallel. You need lots of machines. You need, or just 5 machines. Perhaps you just need 5 nodes. But again, it would be impossible to process with only one.
Got it. Yeah.
So that's the definition I like.
And then, so, you know, a couple of real world scenarios that I'm personally familiar with, like projects that I worked on before, you know, my previous jobs were fraud detection at banks is a very good example of the need for distributed parallel processing, because the idea needs to be that you can detect fraud before it goes on for too long, right? And so with every transaction, you basically need, and it's not necessarily to approve a transaction, but let's say that you're always trying to process or analyze every transaction within 5 minutes of when it happened, right? And then, and then immediately you're running some rules against it. Is this within 100 miles of where they usually spend money? Is it within 200% of the amount they normally spend? Is it, there's all these flags, right? That can basically flag it as potentially a fraudulent transaction. And then if you get 2 or 3 of those flags, then you escalate the issue. And if you're, you know, a massive bank, you need to be doing this at a huge scale, 24 hours a day. And so for me, this was a problem that I worked on quite a bit personally, but immediately lent itself into kind of this big data realm. Another very obvious one is recommendation engines. Like if you're on Amazon or Spotify and they're trying to recommend the next song to you, especially Amazon, eBay, those kinds of things. They're constantly crunching their own data to see people who bought this, what were they most likely to buy next, right? And that's always changing. So I would ask you, what are some other kind of real world use cases that you've maybe personally even worked on, or to help people understand what we use this for?
Yeah, for instance, last year we did a project in a pharmaceutical manufacturing facility here in Hungary. Over there, when the drugs are being produced, they are collecting lots of sensor data, and hundreds of thousands of rows coming per second. It's really very fast growing, and it was Microsoft Azure-based infrastructure, and we were dynamically tracking those sensor data and alerting if something goes strange. It's a bit like anomaly detection, which you described as a fraud detection. But in this pharmaceutical factory, we were detecting some sensors. If it goes off, let's say 3 times standard deviation over the average or down. And we detected some trends as well. So if it's going down, it's going up over time. And basically, the output was an ETL process, and at the end of this ETL process, we write an alerts data set, which is a Spark data frame. We write this Spark data frame to database, which is in Azure. They call it Data Factory. Basically, it's a SQL server. And over there, Power BI reads those alerts, and the engineer sees those alerts in a visual form in their application. So this was the project which I worked last year.
Nice.
And
then ETL, you mentioned the acronym ETL, which is very, very common in the big data realm, but for somebody who's getting started might not have any idea. So ETL is extract, transform, and load, right?
Right, and this is what...
would you mind just explaining kind of what an ETL process is, just in a high level?
Yeah, very high level. Read it from your database, transform it, apply some business logic, and then write it again to another database.
Right.
So this is
at its core.
Yeah. This is what I was doing actually last year. There was a JDBC connection, and I was using that. Basically, I applied all the rules, the alerting rules in Spark to these data frames, and then wrote my results. Yeah, that's what an ETL is.
Got it. And then, so kind of moving forward, what is Spark?
Oh, what's Spark?
High level, obviously.
Yeah, high level, of course. Yeah, I guess I was reading somewhere that 75% of the code is in Scala, and 25% in Java. Spark came as an innovation, on top of Hadoop, we can say. After the hype was over, the big data hype we mentioned at the beginning, we were already in the plateau of productivity, and Spark came into existence during that time period, 2014. And it was a project in Stanford University. And the name of the guy is Matei Zaharia. He was doing his PhD over there, and he's basically the guy who invented Spark. And the most important thing is Spark. The most important thing about Spark is that it is doing in-the-memory computation. Hadoop, when doing the operation in between the tasks, it is reading from the disk and writing to the disk, and it really takes time. However, Spark does everything in the memory. Not everything, but if it's possible. So as the memory as it has enough memory, it uses the memory. If not, and then it starts writing. It's the main difference. It is the innovation Spark brought, and still today they are advertising it. Still today they are advertising it as the lightning speed analytics engine.
Okay.
Of course, it is not like lightning speed if you compare it with a pandas data frame. You know, you are on your machine, you have a small data set, and you can really do it fast. If you load the same data set with Spark, it will be much slow because it is not big data. So
right.
Yeah.
Got it.
So
So
that's what Spark is. So AMP Labs, I think it's called AMP Labs in Stanford University.
Okay.
And
so yeah, go ahead. Sorry.
Yeah, and they and they invented this product also called DataBricks. So to productionize, to make it as a product. So they came with the idea and they formed this company called DataBricks, which would distribute this Spark to all over the world.
Got it.
Yeah.
And so that's what we're going to take a look at today. You're going to give us a bit of a demo on how to use DataBricks, load some data, read some data, filter it, analyze it a little bit.
Yeah, I will do that. And perhaps I should share my screen, right?
Yeah, let's go ahead and jump into it. This has been great. I appreciate setting the context, because especially for this talk, and potentially our audience members who are kind of just learning to code, laying some contextual groundwork here about what it is that we're talking about, because it's kind of a higher level concept, is great. So thank you for taking the time there. And yeah, let's go ahead. I need to give you the ability to share.
So this is the product we talked about called DataBricks. And you can really log in very easily to the community edition. This is the community edition of DataBricks, which is for free, and it makes you process with Spark for free, which is great. And perhaps I mentioned, perhaps not, I don't remember, but this product works in the cloud. So in order to have some data, you need to mount your Amazon S3 bucket or Azure Blob. Yeah. However, they made some data sets readily available for us to prototype, teach, learn, and I will try to show that to you. When you log in, you will see a screen such like this one, and you will see the clusters here. This is how we create a cluster. I just give a random name. Today is Monday, right? I hope it's Monday.
Yep, today's Monday.
Yeah, perfect.
I had to
and we can select a runtime as well. I will select 6.5 because it just assigned to 6.5. Why not? And you see there are different runtimes here, and there are 12 more. For instance, if you select an ML environment, you will have scikit-learn, NumPy, all those packages readily available in this cluster. The one I am selecting right now does not have any of that, but it is enough for our purpose. If you want to try Matplotlib or Seaborn visualization libraries, you should select the ML one. Also, you see GPU here, graphical processing unit. So if you are running some deep learning experiments, you should select an environment with GPU as well. Okay, let's start this cluster.
And did you indicate how many nodes that you want, or does it?
Yeah, since this is the community edition, we are not.
Okay.
It is establishing parallelism by using the cores in a single machine. So in the community edition, we don't have those nodes. However, I used also the professional edition in my work. Over there, yes, you select, and it's actually an important part of the process, because if you say DataBricks pricing calculator and search for it, you will see for different configurations, you will pay different. Here I am selecting Amazon Web Services. Yeah, let's say I want to calculate something. Let's say I will run 5 hours per day and I have 19 days per month and I will need 20 instances. This is going to be my approximate cost.
Yeah, it goes up quick.
Yeah.
Nice.
And you can and you can check out your cost also here, all-purpose compute. So these are the EC2 instances of AWS, and you can make some rough calculations over here.
And so when you set up a DataBricks cluster, under the covers, DataBricks is initializing this on whatever cloud you select, for instance.
Yes.
AWS or Microsoft Azure.
Yes, exactly. Yeah, currently it works only with AWS and Azure.
Right. Okay.
Okay. And okay, this means the cluster is ready. It's green. Now we have our cluster up and running. Let's create a notebook. One sec. So this is your workspace, users. Currently, this is my account. This is my personal account, by the way. And I have some prototyping here already. And I think I'm gonna, yes, this was the one. So if I attach this is how I attach my notebook to the cluster. And when I see this green light, it means I can run. Okay, so this is our notebook environment. We see that we are in command number 1, and then our notebook is up and running, just like we have here. We have access to some magic commands, which I want to show you. So this fs, and if I say ls, it will look familiar to you because this is a Linux command, and the magic command in DataBricks is fs, which means file system, I guess.
Yeah.
And the first command is taking some time. So because we need some quick prototyping and some teaching and learning purposes, they already have data sets readily available over here. Nice. DBFS stands for the DataBricks file system. And if we actually do the ls command on using this, oops, I pasted through. So here they are loading lots of data. The last one I saw was the COVID data. You can go ahead and play with this data as well. For the time being, I want to check the bike sharing data with you.
Okay. And so anytime you set up a little cluster like we've done here, you'll have access to these sample data sets, correct?
Yes.
Got it.
Yes. They made this available basically because, you know, it makes it really easy for starters to have some data.
Right.
Mounting your S3 or mounting your Azure blob can be, you know, a bit hard for the beginners. But when you have these data sets ready and available, you can practice Spark. You can learn about big data processing on your own. And this would be my recommendation also to the people who are interested in big data computing. You can go ahead and sign up for this community edition, start your cluster, and learn Spark. And it's a great addition to your tool belt, in my opinion, or to your CV. Over here, we have data 001. Let me remember what I had inside. Yeah, we have basically 2 data sets here, 2 CSV files. One is hourly, one is daily. And I want to read this one. And First, before reading, I want to check how it looks like. What we see here is, okay, this is comma separated, obviously. We have columns and we have different data types. We have date, right? We have some integers, we have some floating point numbers, and we want to read this to a Spark data frame. Before reading Spark data frame, I want to introduce you the Spark user menu. One sec, I had it here somewhere. This is the single most important documentation for using Spark.
Right.
The difference between a very productive developer and a very lame developer could be as simple as this website, to be honest. So over here, you select, for instance, for me, it's Python. So I go ahead here, and they have these modules and packages. By far, the most important one is this one, PySpark SQL functions.
Okay.
This module makes a lot of things possible really fast and easy. You might have a problem like finding the intersect of two large data sets, and you can try on your own lots of algorithms, lots of different functions. However, over here, if you go into this module and look for your problem, probably you will find it. There's a really fast implementation over here. The other ones, we see that there are lots of ML packages for machine learning. We have the streaming one, but my recommendation is to master this one, PySpark SQL functions module. And to search for what we are looking for instance, we have the bar here, and we can say read CSV, and we find it. And then it will jump to reading CSV, and it will introduce you all the parameters you can use. For instance, this was one of my last searches, the intersect. So we have the intersect function here already. It is really simple. Return a new data frame containing rows only in both this data frame and the other data frame. And that's it. You just need to call this function. It's really simple.
Yeah. And
So
that can be a very difficult problem, right?
Yes, sometimes this can be really difficult. This is just an example, but there are really complex problems which you can solve by just calling one single function. And it's really like a superpower. Most of the time, me also, I mean, my colleagues also, sometimes we forget looking at here, and it's a big mistake. First, we should identify our problem, and then we should look for it here in this module, PySpark SQL functions.
Okay.
Okay, let's go ahead and read our data now. I will call it EF with big letters because the data is big, right?
Okay. Yeah.
Yeah. So we should just say Spark read CSV. And let's define our path, right? Let's copy paste this thing as our path. You see it is sending to cluster now, and the first computation is taking generally more time, so 7.8 seconds. So this is a lot.
Mm-hmm.
That's why some people have this frustration when they try this, you know, they say, come on, this is slow.
Understandably, yeah. But it's not meant for...
Yeah, it's not meant for this data, it is for big data.
Right.
And this display command is only available on DataBricks. And we see that it is in a mess, you know, I didn't define my headers and, you know, and not only that, but if we print the schema, this is how we print schema. It is just a bunch of strings, and all the data for all of them are strings. So it didn't understand also the data types.
Right.
So
and just for context here, typically, this is a normal problem when reading in a CSV file, because CSV files are, when you read them in, even if they contain nothing but numbers, they're read in as text typically in programming.
Yeah.
Like words rather than numbers. So that's where the, just for context there, yeah.
Yeah, and one sec. I want to show it in the module, the read CSV. So because it gave me a bunch of garbage like that, I want my data formats and everything, my headers. I can actually find parameters here. So when I am reading the file, I can use this header as an option. And that's what I will do here. So we can use these options like this, and we will just say header is true. And then we will read it again. And now it looks better.
And it was a much faster, am I reading that right, that this second one took 0.7 seconds?
Yes, because it already cached, I guess, something. Yeah.
So it gets faster.
Much faster. And however, the data types are still, all of them are string. For that, in Spark, we have another option when we are reading the data. It is import schema.
Nice.
And import schema will be also true. And if we run that again, and let's print the schema. Now it looks much better. I have my timestamp, integers, and doubles. So this is what I wanted. Whenever we are reading the data, we can use these kind of options to make it read it properly.
Nice.
So this was the key takeaway I wanted to mention here.
And just to interrupt real quick, I always singing the praises of documentation. It took me years as a developer to really start referring to documentation religiously, right? I would always go look at forums and Stack Overflow and all this kind of stuff. And what the good people are doing is, sure, you can check forums and Stack Overflow and all that kind of stuff, but what the good people are doing, the people with the answers, they're always linking you to some documentation. The answer is in the docs, and just by if you never read that that documentation page that Shadash just mentioned, it's going to be confusing forever. But if you just spend a little bit of time reading over the documentation as to what your various options are and then experiment with them, you get exponentially better, much faster.
100% agree.
Yeah.
I learned that by crying so many days and nights.
Yeah, me too.
That intersect thing was a major problem for me. For instance, in one of the projects, I didn't know how to use that intersect function, and I lost lots of time. Yeah. Yeah.
And then you read the docs and you feel, you want to bang your head against the keyboard. But
yes. Yes, that's why whenever I start talking about these things, I first recommend reading PySpark SQL functions module and this documentation I mentioned here. Yeah, always read these.
And it's not, I completely agree. And it's not like you need to read it and memorize it like the first time that you've come, let's say if you're listening to this video, you don't need to come in here and read this like you're about to take a test on it. It's about becoming aware of what some of your options might be.
Yes.
Later when you're writing some code, you're like, oh, there's that.
Yeah, it's a superpower to know where you can find something.
Nice. I like that. Superpower.
Yeah, it's not about memorizing these things. It's about knowing where they are and how to search.
Right.
Yeah. And now that we read our data set, let's have a look how we can filter and how we can select the columns we want, because we have lots of columns here, but I don't want to do analysis on all of them. I just want to select a few of them, and then I want to filter. I want, for instance, the months. Obviously, we have months here somewhere. Yeah. For instance, I want the months greater than 4. Yeah, after April. Let me do that. I will call that df2, and I will create it. I will create it by using the df, which we already have, and we have this select function, and I need the year. I think it is YR over there. I am reading from the schema. I have the month and the temperature, and of course the count. These counts are the number of bikes which were rented on that day. So I am telling Spark here to give me only these 4 columns and filter. And this filter should be the month. What we were saying greater than 4. Yeah, and the month, let's say smaller than 9. Let's see if this will work. Okay, it worked. And you didn't see anything. Isn't it surprising?
Right.
So we didn't see anything here because obviously we are not printing anything. But even if I write here, this one, it will just say it's a data frame. Because Spark computes in a different way. This is called lazy transformation. It means it is recording what I want, and it is not triggering it until it is necessary. And it is using an optimization under the hood. When there is an action, it is triggering everything, and it creates a tree of everything to do. You might have some complex transformations, lots of transformation cells, and at the end, when you call the action, it will trigger and it will know which one to do first. It will optimize it, and then it will run the job. But it's not going to run this. It's not going to run this if I am not triggering any action. So these are the basic concepts of Spark.
And that triggering action, it might be also would be called like a terminal function, right? So the actual computation of all the steps isn't executed until there's some kind of terminal operation. Is that correct?
Yeah, I never used that terminal word when I was learning or describing this.
Okay.
We always call this transformation and action.
Okay.
Transformations create a data set, such like this one, and they don't trigger the job. So this is the terminology we should use, in my opinion.
Yep, that works.
Yeah, yeah. Otherwise, I don't know what terminal you mentioned.
No
Perhaps
problem.
it can be the right term as well, but I've never heard about it. Yeah. However, we didn't see this data set yet. I want to show it using this display command again, because I want to see how this df2 looks like. Great, this is what I wanted. So we selected 4 columns, and we have the months also in the filtered.
May through August.
Right? Mm-hmm. Yeah. Yeah, it is from May to August, right? Okay. Fantastic. 1 sec. Over here, next we can do something. So we are using lots of if-else when we are writing some Python program. For instance, I want to show how to write something like if-else in a Spark data frame. And for that, I want to create a new column here, which is called summer. And this summer column will have two values, true or false. If the month is a summer month, it's going to be true. If it is not summer, it's going to be false. So it's a Boolean column, which I will create, and hopefully it's going to be a good example, perhaps. I want to write it fast. So, but first I want to import my library from PySpark SQL functions. Here, what I did is I imported all the functions from the library I mentioned to you from this one, PySpark SQL module. And over there, I want to use some functions, and let me show that. Okay, so df2. Whenever we need to create a new column in Spark, we use this with column. And we will use the function called when here. I just want to demonstrate how we are using this. So I will skip May. Okay. Here the syntax is when column month is greater than 5, make it true. Otherwise, just say that it's false. And let's see if we can run this. Okay, this is what I wanted to show.
Nice.
So the summer months will be coded here as true.
Mm-hmm.
Okay, so this is how to use the when otherwise terminology
Right.
in Spark, and it's a kind of if else, right?
And it's very intuitive.
Yeah, this is what I like actually about these functions and Spark. By the way, we are using Spark data frames. I know some people, they are doing everything with SQL, so it is possible to use SQL also.
Okay.
At the beginning, when I introduce you this documentation, let me go there back. This was our home screen, and currently I am using Python, but you can do everything with SQL or Java, Scala.
Right.
Right. Okay. One more note about actions. So for instance, when I count the rows, it's an action, it triggers. So this is a job, and you can track it in the UI if it opens. So there are lots of information about your jobs here. And this UI is available even if you are not using DataBricks.
Is that, would I be correct in thinking that those are map reduce jobs that are happening under the covers?
Yes.
Got it.
Definitely, yeah. And over here somewhere, there are nice visualizations as well. I hope I can find it. Oops, I lost it. This doesn't want to respond. Let me try one more time and then I will skip. Okay, yes. Anyway, this takes time. I will just skip that part.
No problem.
Yeah, I just wanted to demonstrate a job. So because we want to count how many rows here, it is not a transformation. And it needs to trigger the job, and it gives the result back to the driver.
Mm-hmm.
Let me see what we can do next. Okay. We can next try one of the most common things we do, how to group by, right?
Mm-hmm.
And when we are doing analysis, most of the time we group by our data based on some categories. In here, I want to group by month, and I want to sum these counts. I want to sum up these counts by month. So that's the objective. And how group by works, let's first drop the year. I don't want to see that. And I don't want to see temperature as well. And from that, I want to group by. It is again quite intuitive. I'm just saying that group by month and sum them up. That's all. Okay, let's try this out. Let's display this final DF. And then yes, this is how we group by. It took some time, look again, 4.5 seconds. This is a small data set, and these are really taking some time. Under the hood, some shuffles happened. So when there is a group by, it triggers a shuffle. Shuffle means data communication between the nodes. It's a white transformation, which means when you filter something in your data set, the partitions don't need to communicate between themselves. Everyone can filter. By everyone, I mean the nodes. The nodes can filter their data on their own.
Right.
However, when you group by, the things are a bit different. They need to communicate between themselves. The nodes should communicate to understand the correct number of the sums. It is called a white transformation. That's why it can take more time.
Right.
So the difference between white and narrow transformation is important when you want to compute a large data set, because some jobs can take a lot of time in the real life. Here, I don't like the name of this column. It's called sum parentheses CNT something something. For that, for renaming, we use with column renamed. As you can see, everything is quite intuitive and simple if you know which function you will call. I think back in 2014, 15, it was much more difficult. These Spark data frames were not ready during those days. And yeah, however, now, as you can see, these are relatively simple.
Yeah, it's really, I'm really impressed by how intuitive the syntax is. You can read it, like English.
Yeah.
Nice.
So I changed the column. And of course, when we are doing the analysis and if we are preparing some data set for some analysts or data scientists, they might ask some order by as well, right? And we can simply call the order by as well. Order by, I want to order by month. So now the months are also ordered.
Looks like everybody likes to ride bikes in August.
Surprise, surprise. And there is one more thing here which I want to mention. There is also a built-in visualization tool here. It's here. When you click on that, it will already create some plots which you can copy paste into your presentations or your emails.
Nice.
And you have the plot options, and you can define what is your X and what is your Y. And you can change the bar charts. You see there are lots of charts here which you can use, but in this one I want to use bar chart. So we see that months are in our x-axis, 5, 6, 7, 8, and the sum of bike rentals are increasing over time. If you want to go back to the tabular data, you just click this. Yeah.
Nice.
Yeah, this is also a nice feature which I like.
Yeah, it's superpower. Superpowers are the right words here.
Yeah, they are trying to enable people doing lightning fast analytics. That's their buzzword. They call themselves AI company. I mean, DataBricks. It's a buzzword, of course. When you go to their homepage, DataBricks. Let's go to the first one. Try data. No, I don't want to try DataBricks. Yes, this one. So they say unified platform for data and AI. So this AI part is a bit marketing, but they are really pushing forward, as you can see.
Yeah.
You can create all these beautiful dashboards and you can schedule them. What is nice with DataBricks environment is that I can create this notebook and I can schedule it to run every night after midnight. And every morning when my analysts are in the office, they can find this already ready with the new data. The job scheduler, I don't know if it is available over here in the community edition. Perhaps it is. Let me see.
Yeah, so I mean,
but I don't know. Anyway.
Yeah, this is nice though. I can see how companies could use DataBricks basically to build, even just internal dashboards on their data sets to understand, where users are spending time on their sites and, any myriad of problems. But what's new to me is I didn't know previously that DataBricks could be used kind of to build dashboards, internal dashboards for the team and for clients, etc.
Oh, definitely. We did that last year for the pharmaceutical I mentioned to you. It was one of the nicest moments during the presentation. There was competition between another company and us. The other company was not an open source, but a famous old company. And everything we presented was really cool. But in the end, we also showed the dashboard functionality, and it was really effective that we could produce dashboards and run them after midnight. And in the morning when they arrive, they would see the updated dashboards already.
Nice.
These are really nice features. And when I was talking, I also called this function, get num partitions. This is how we check how many partitions we have in this data. So obviously this data is very small, only 4 rows, but it's already consists of 4 partitions, which means 4 chunks. That's how Spark is working. It is dividing the data into several chunks, and you can define how many chunks you want, actually. You can set that up. You can say that I need 100 partitions, and then it will divide it to 100 and process them. And to see how many partitions you have, you just call this. In the community edition, of course, this doesn't make much sense, but in the real world, when you have 20 EC2 instances and you have, I don't know, 100 terabytes of data, then you will need to do some calculation in the spreadsheets first.
Right.
Because it depends. If you select your course wrongly, then the computation time can double easily. Yeah.
And that sounds interesting, but more kind of a higher order problem.
Yeah.
maybe a little bit out of
Yeah.
scope for this conversation.
Yeah.
I see where you're
Yeah.
going.
Yeah. Okay.
But nice.
So I will make this notebook available. I think this was all I wanted to share for today.
Okay.
Yeah, but if you have any other questions, I don't know. We can continue as well.
No, this is great. This has been really informative, and honestly, pretty shocking how far it's come. I haven't logged into DataBricks in a very long time, and it's really cool to see how much progress they've made and how intuitive this is. And already my mind's thinking, what the opportunity, the possibilities of what you can do with this are vast, right?
Right.
I mean, and just with the sample data sets they provide, but the neat thing now is that data sets are more and more available, right? So all over the, there's one website I use a lot called data.world.
Yeah, I use that as well.
Nice. It just has a nice collection of data sets that you can use. So whatever it is that you're interested in, something that we do in our classes a lot is do analysis on, there's a really cool data set. It's not necessarily big data, but it's a neat data set that basically tracks all the immigration and emigration in and out of people from every country in the world for the last 30 or 40 or 50 years. It's from the UN. It's a really neat data set to try to understand kind of where people are going and when, and especially in one of the challenges we always do is if you try to join that or intersect that in a way, I guess probably wouldn't be an intersect, but for instance, with weather data, right? Is there any association with extreme weather data and, and the movement of people around the world? And honestly, doing it here in DataBricks seems a lot simpler than than some of the other ways that we've done it before. So, the possibilities are endless. I'm excited to play around with this. I'm typically more of a Java guy, but to see that they have a Java API and a SQL API, I'm getting stronger with my Python.
Yeah.
But, it's really neat.
Yeah. Basically, you can integrate all your SQL queries and use it. And its optimization, which is running under the hood, is also great.
Yeah.
It is called Catalyst Optimizer. You can look it up in the documentation, and it really doesn't matter how you write the query. It understands what you are trying to do, and there are some concepts like predicate pushdown and so on. It is optimizing your query, or it is optimizing what you are trying to achieve under the hood, and it is giving the results. Yeah, which I like a lot.
The sheer number of abstractions.
Yeah. Unbelievable.
Powers or standing on the shoulder of giants, I think, like you mentioned earlier, it's incredible the kind of stuff we can do now and how simply we can do it because of just how much work has been put in under the hood for so many decades, that it all builds on it. This is a clear example of us making some really
Right.
Nice. Well, Shadas, thank you so much for your time. I really appreciate it. Thank you for the mentorship that you've done with Coding Nomads. Thank you for sharing your knowledge with us. This is just really neat. And any other closing words or anything you'd like to say before we go?
It's my pleasure. Yeah, I really enjoyed doing this volunteering work during the COVID crisis. It was really exciting to know people around the globe. I really enjoyed it a lot.
Wonderful.
I just want to say hi to everyone.
Nice.
And that's all.
Wonderful. Well, thank you again. And we'll make, go ahead and share that. I'm not sure how you can share that notebook, but if there's any resources that you can send to me, even just this video,
yes.
And I'll make, even on our Coding Nomads GitHub, there's a Tech Talk repo, and inside the repo for this chat, which will be kind of intro to Spark and DataBricks, I'll have a read, which can even just have a couple of steps or anything like that. So any kind of resources you can send me would be great. And
another nice functionality here is that I can export this notebook and send you, and you can run this in your own DataBricks Community Edition, so it will be easy.
Nice, very nice, great. Well, thank you again, Shadas. This has been really great. I really appreciate it, and enjoy the rest of your day.
Yeah, enjoy. Bye.
Bye.
Hey everyone, thanks for watching. If you enjoyed this video, please let us know by liking and subscribing. If there's another topic that you'd like to learn more about, leave us a comment. We would love to hear from you. And if you want to become a coding pro, visit our website at codingnomads.co. See you next time.